so much. Thank you so much. This is amazing. I'm extremely grateful and honored to be here, to have you all today, so early in the morning. Really appreciate it. I mean, this is PyCon, right? This is the good stuff. In-depth talks, people who have achieved amazing projects. And, I was really struggling with the idea of my talk. I was like, how am I going to say anything that is relevant to this audience? I don't even know this audience. I've never been to Pakistan. This is my first trip to Pakistan. And that got me thinking, hey, even though I've never been to Pakistan, I know for a fact that if I go to PyCon, I will meet people who are just as excited about programming and Python than myself. And I think that's very powerful, because at the end of the day, programming, for many of us, it's also a job. And jobs are usually associated with constraints and sometimes suffering. So how do we reconcile that? I thought there was a mystery there, and I thought I could talk about that. Please indulge me. I'm going to talk about myself for the first few minutes. So I'm in this weird transition period where I'm going from a job where I was programming to a new position where I'm not sure. I ask people to do programming. I'm still figuring out this whole management thing. The point is that I've been thinking a lot for the past couple of years about what I really enjoy in programming and where that even comes from. And there are so many threads in my life that connect back to a single event that happened when I was 6. Again, please indulge me. And on that day, Santa Claus brought me a Nintendo Entertainment System, also called Famicom. And it was this big gray box, very angular, small red dots. And you connected controllers in there, connected to this big TV, turn it on, and then boom, pixels. Not so many of them. And I thought it was amazing. I want to show you that. This was the most amazing thing ever. I didn't expect that. Let's try again. Yeah, and this was amazing to me as a 6-year-old, because it was as if this thing was talking to me. It was challenging me in the most brutal ways, but also rewarding me at times when I succeeded. I spent a lot of time on this game. I did. Yeah, I did spend a lot of time. And if I'm being honest, I think I spent way too much time on this game, because there were some problems that I knew I could not address. I had a very happy childhood, but some problems were just too difficult for me, and playing video games allowed me not to think about them. And really, playing video games opened whole new universes to me. It opened me to new images. It really built my musical tastes. Got me into science fiction, role-playing games, really defined my tastes in movies. Later on, I became interested in computers, and that became my job. In the process, I made many friends who are still to this day some of my best friends. So I thought that was very powerful. Okay. I know what you might be thinking. This guy is nostalgic. I'm not. Not at all. I don't want to go back to that time when I was playing video games all day. I'm a different person now. I don't think I would enjoy that so much. But still, the passion. I've been doing web development for about 10 years now. And I'm not really happy with the state of the web development anymore. I think in too many ways it's really bloated. And in case you're wondering, I am thinking about NPM and Kubernetes. I'm super happy with Django and Python, but the rest of the stack just makes me very unhappy. But it is really fruitless to try to go back to that time when I was happy as a child. I mean, yeah, sure, I could go back to playing video games all day. That would make me satisfied for a while, but then I would get bored with it. And I would need to find something else to satisfy me. I would eventually find something, work very hard to get it, eventually grow tired of it yet again. You see where this is going, right? So what I'm describing is really this ever-spinning wheel of desire and suffering. And if you're not familiar with this concept, it's really the idea that you cannot be happy if you are led with desire. Because desire leads to boredom, frustration, and suffering. This is a concept that is really rooted in philosophy and even religion, and not everyone might agree with it. And I get that. So I presented that concept in a format that is more relatable to our software engineer minds. I put that into the form of a Gantt chart. What this Gantt chart tells us is that, we can try to accomplish our desires, and it will make us happy for a while. The customer might be happy as well, but eventually the customer will come back with a new feature request, and we will investigate it, do the product design, work on it, and produce it, and the customer will be happy and come back with a new feature, etc., etc. And this is really this is only a path to misery and suffering. You could say that this is really a concept that applies to capitalism and businesses in general. Let's not go there today. So how do we get happy as software engineers? Turns out there is a way. Let me show you. The trick to escape this ever-going path of life and suffering is really hidden in plain sight. And once you know it's there, it's rather easy to get there. It's kind of like a warp zone. So the trick is just to ignore all of this. And just enjoy the journey. And then you get there. It's like a warp zone. So, as a kid, I never quite figured out this warp zone. I mean, this is in level 4, and this warp zone leads you to either level 6, 7, or 8. 8 is the last level. Why would anyone in the world ever go to this pipe? Doesn't make any sense. That was my reasoning as a kid. I mean, I would go straight to the end, right? But this is Mario telling us, hey man, I know you are suffering. This game is brutal. I'll make it slightly easier for you. You can go straight to level 8. By the way, it is super hard. But you know what? We spend a lot of time working on this game. We think it is amazing. We think you'll love it. So you should definitely try out level 6 and 7. They will just blow your mind. And yeah, you can come back to level 4, complete it. It's also pretty good. And try out level 5 at some point. Yeah, just come back anytime. So this trick that I'm talking about to escape this path of never-ending misery is really to enjoy the journey. And I wish I had come up with that. I didn't. The trick to enjoy the journey is to be happy. It's to be happy. It's to be content with what we are, what we do. How do we do that as software engineers? Again, this is a question that I ask myself a lot for the past few years now. And to prepare for this talk, I asked the same question to my friends who are software engineers. And I expected to get very consistent answers. I did not at all. It's like everybody has extremely different answers on what makes them happy with programming. Generally speaking, the things that make us happy stem either from ourselves or from other people. On the top half are the things that make us happy. And we have to understand what are the things that make us unhappy if we are to become happier. So a big theme that really emerged was this idea of building stuff. When we program, we have this design in our mind, and we start putting blocks together, and it just fits. It's like a Lego game. In the process, we face some bugs, we troubleshoot them, and this architecture becomes very reliable. It can accomplish amazing things. In the process, we like to enjoy this what is called flow, but what is really serenity, this inner peace of mind, the mental quietness. I like to listen to music when I code. And of course, the money is good too, as software engineers. But then some of the biggest, the most rewarding things when it comes to programming come from other people. This sense of usefulness, of helpfulness. Yes, we're being helpful to our fellow humans. This enhances our sense of purpose and helps us leave a legacy behind. And in the process, there's this, the collaboration is extremely enjoyable. There are the jokes that we crack at the office, all this. And then, I guess we need to talk about the bottom half. The compromises that we have to make in order to ship in time, the distractions that break our flow, all these interruptions that sometimes accumulate. In order to go where we want to go, we need to bypass some obstacles, and an obstacle leads to another obstacle. And at some point we decide, sure, I'll try and resolve this. And then this issue leads to another issue, which hasn't been resolved either. And we try to resolve this other one, and a process that is called yak shaving. And that is not very enjoyable, as you all know. This leads to discouragement and frustration. Bloated software calls this very often. And then, just like our interaction with other people bring us the most happiness, it can also bring us the most unhappiness, the most suffering. Because humans, they are so difficult. I mean, the misunderstandings, the conflicts. We are social animals, and yet it is so difficult. We have pressure due to deadlines or management. How do we deal with this? As an open source maintainer, let me tell you, there are plenty of opportunities for conflicts and misunderstandings. So when someone opens an issue on GitHub and they say it does not work on Windows, maybe what they really need to say is that, hey, they did try really hard, But they're not so familiar with this programming and GitHub thing. And all they had was a Windows machine. By the way, they don't speak English very well, so maybe they didn't quite figure out the documentation. If you could provide me with just any help, I would really love it. And by the way, my job is kind of on the line here. Thank you so much. But they don't have the time to write all this, of course. And similarly, as a maintainer, I would be tempted to answer to this issue. This is intended behavior. Please read the docs. Closing this has one fix. But what I do mean to say is, hey, man, I'm really sorry. I know the issue that you're facing. Several other people have had it before. I don't have time right now to point you to the right section of the docs, because there's some fire going on in my kitchen. By the way, CI is broken. There was just recently a vulnerability disclosure. And by the way, this is a hobby. I'm not paid for this. I wish I could do more for you. Good luck. And then there are colleagues. I would like to pay homage to the best colleague I ever had. His name was Richard. He died at the beginning of the COVID pandemic. And we were working together on this in this company education project, and we used to have these huge fights because we did not agree on how to implement a feature. On should we design a nice architecture or do a quick fix? But we knew that making a quick fix would lead us to problems along the way. Lots of conflicts. But then in the evening, we were very good friends, used to have drinks. Colleagues can be, of course, very precious to bring happiness in the life of engineers. And Richard was really passionate about teaching and learning. And what I realized in the past few years is that something that brings me the most joy in programming is teaching people. So with a friend, two friends actually, we started a code club in the small town where we live. It is a code club where we teach mostly kids to program using video games. And let me tell you, this is amazing. If there's just one takeaway from this talk, is that you should be starting a code club. So when we talk about video game programming, in the beginning it's like displaying a screen with a white square in the middle. Let me show you. And disclaimer, we usually don't use Python for that, because Python is just too much boilerplate for kids. So we teach the kids to build the screen with this white square in the middle, and then they have to code the action that moves the white square to the right when we press the right key. And there's usually a lot of struggle to accomplish that. So this is the code in Loft2D. It's a framework for Lua. It is amazing. So there are many things going on there. You need to learn about variables, which are not intuitive at all for kids. You need to learn about coordinate systems. Again, and by the way, the coordinate system is upside down compared to what they already know. You need to understand what is a function. You need to understand if conditions and variable assignments. But then let me tell you, when the kid presses the right key and the white square moves to the right, oh, this is the most amazing feeling ever. This is pure bliss. So starting Code Club, it's not difficult. You need 4 things. You need a place. You need computers. You need to tell people about it. And you need to show up. That's it. And what you don't need is a curriculum. Kids, in 2024, they know what they want to do with software. And the first thing that you should ask them is really, what do you want to do? And depending on their answers, you might lead them to different tools. We like to start with Scratch. I assume everybody's familiar with Scratch. Scratch is an amazing visual block-based programming language created by the MIT. It is extremely powerful, and it exists in many languages. So when we teach kids who are not native English speakers, it's super useful. There are two issues with Scratch. It's that kids might be feeling that they are not doing real programming, and then this might frustrate them. Also, they can't often learn Scratch in school, so they might think, okay, this looks way too much like school. And then the other thing that might frustrate kids is what did I want to say again? So Scratch is really designed to let kids explore on their own. And this doesn't work so well anymore because whenever they have Scratch open in a tab, YouTube is just one another tab away, and it's really difficult to get them to focus on what you have to do. Anybody know about microbit? Microbit it's a piece of hardware. It's not very expensive, and you can also program it using a visual block-based web interface. And it has quite a few sensors. There are buttons. There's a sound sensor, a microphone, a gyroscope, a compass, and what else? Temperature, did I mention that? And there's a 5x5 LED screen. So I want to show you what it can do. There's this emulator there online. Let me zoom out. I created a game for this conference talk. It's a Flappy Bird version, so I called it PyCon. And it's not a big program. It's bigger than what most beginners would do, but it's still fairly simple. I mean, it was simple to create this. Let me show you. We start by pressing the B button, and then we jump using this, and we have to avoid obstacles. I mean, not too hard, right? That works. Am I getting lucky? And this generates obstacles randomly. This is just meant to show you like what the things that you can do with microbits, and so kids enjoy it very much. I want to convince you more, so I'm going to try this. This thing working? Yeah. I want to show you how this works. So I connected the jump command, a Flappycon, to the sound sensor, to the microphone. Do you see where this is going? Okay, so you are going to control the bird by clapping. Can we try that? Can you do a big clap? No, it has to be like clap, and that's it. Got it. Okay, sound sensor seems to work. Okay, I'll try this. This is a tricky demo. So let me try this. I'm going to press the button, and then you have to like somehow cooperate to make like a single clap to make the Flappy Bird avoid the obstacle. That works for you? That works for you? Okay, cool. Let's try this. Go. Oh no, it didn't start. Well, you should only clap to make the bird fly, not like only to avoid obstacles. This is not working at all. This is not working at all. Okay, you did. Yeah, that was a difficult demo. I have a worse demo later. But kidding aside, this thing, it is great. It is really great. And the really cool thing is that Microbit can convert block code to Python code or JavaScript, but I don't know why would anyone want to do that. So this big code that I showed you, it translates to about 120 lines of Python, which is totally readable. And I think this is great to have kids transition from visual block programming to, again, these real languages, not my quote. So another big issue is that we face when we teach kids is that many of them don't know how to type. And if we ask them to just write Python code, it's going to be extremely frustrating. I'm talking 3 keystrokes a minute. And you're going to be like, I want to type this. So we should teach kids to type on a keyboard. And this is the 21st century. There are web apps for that. I personally recommend Heber. Once they have acquired this skill set, they can learn how to write code. And I wish I could really pitch Python and Pygame for that. And sometimes I do, because kids come to us and say, I want to do Python. I'm like, for video game programming? Yes. Are you sure? Yes. Okay, let's do it. But then I would really recommend Love2D, which is a framework for Lua. Lua is a great programming language. It is very simple, super easy to understand when you know Python. The only difference is that they have this concept of tables, where dictionaries and lists are basically the same thing, but lists are dictionaries with integer keys. But truly, the kids, when they show up, they want to do 3D programming. They want to code Fortnite. And I'm like, yeah, you really want to do Unity and all this stuff. And it's, because, again, most video games today, they're not Mario Bros. Anymore. They are 3D. We're in luck. There's this library called Raylib, which is really great for that. It's a very small C library that has bindings for practically every language out there, including Python. And you can do 3D programming with it. It is very peculiar in the sense that there is zero documentation, and that is on purpose. And we are supposed to learn by reading example code and looking at the C source code. And honestly, it's very readable. So I think it's possible. I'd like to show you, because I didn't show you much Python code so far. I'd like to show you the, let me close this. Let me close this. I'd like to show you the source code for a game that I programmed here for this talk. I wanted to do something that made sense from a Python perspective, and I was like, okay, so what kind of 3D game can I create? What is Python good at? Scripting, web development, and AI, right? AI. I used to work in the field at the time when it was called machine learning. So machine learning, yes. And we have these amazing libraries today that just do everything for you. You don't have to know anything about the models behind, and it detects stuff in real time in a video streaming, and it can detect so many types of objects. I mean, this is what I was working on when I was doing my PhD. So let me show you. I called it Starfighter 2000 because, hey, why not? And this is just using, issues. Oh, right, webcam is not connected. Fingers crossed. And yeah, it just works, you know? Yeah, just works. And you can detect multiple people. So it's really cool. So I created a game around this. So this is just a detect function. So a game in the basic structure of a game is really just a load function at the beginning of the game, then an infinite loop in which we call the update function, passing the delta time argument, and then draw. So this is fairly standard structure. Here, the load function loads the scene, the player, and the bonus objects. Again, the update function just updates the players and the bonuses. And the draw functions, you guessed it, well, it also draws the player and bonus, but then we need to tell Raylib to begin drawing and then start 3D mode. We exit 3D mode. I guess I should have made a context manager here. And then we draw a high score in the top left corner. The scene code is really just boilerplate. We just create a camera in 3D space where we have a position. Here we create the bonuses in the load function, the class method. We load a 3D model. So if you're not familiar with 3D game programming, you might not know what 3D assets are. I wasn't, to be honest. If you need to visualize 3D assets, I recommend this tool called Fed, F3D. It was created by a friend of mine. And this is what the bonus looks like. So just a regular ball. This was sampled from the internet. I should quote the guy who created this. Unfortunately, I can't remember. So what are we going to do with this? We create many instances of bonuses that are going to be falling from the sky falling from the sky here. So the sky is Y at random heights, anywhere between 4 and 50 meters, and it's going to be these bonuses are going to appear randomly on the XY axis, and we're going to make the bonuses fall down at a constant falling speed. And this is where we draw this is getting somewhere, I swear. And then this is a tracker function that uses this YOLO model. I love the fact that I don't have to think about models at all. This just makes it so much easier. We read frame from the webcam, then detect people. Okay, this is the boilerplate code where we just convert the image to 2D coordinates. This is slightly tricky, the back project function. So we have these coordinates in 2D and we want to back project them in 3D. So I mean, any research engineer doing 3D reconstruction would yell at this because this is very basic trigonometry. You can review that later. Oh, by the way, the code will be available. And then, the players, we initiate them, update them based on their positions, and draw them. Yeah, very basic. And then we draw the high scores in the top left corner. So we just, write the player image with some text indicating their score. Yeah. Who wants to play this? I'll show you how it's played. Okay. Do we have volunteers? I need 2 volunteers. Yes, thank you. I need a second volunteer. Oh, thank you so much, boys. So I didn't plan for this, obviously. Can we try this here? Okay. So the goal is to capture as many bonuses as possible, and we all compete against each other. Yeah, I don't think it looked at the screen, so it should be fine. Are you ready for a failed demo? Yeah. You got this. Okay. There are 100 bonuses falling from the sky. Oh, result with exception set. Oh, because the webcam is still open here. Oh, there you go. I need to stop this. You'll be useful in a second. There you go. So we need to capture the bonuses. Oh, what?
Yeah,
you have to move to figure out where you are.
okay.
Wait, I'm not sure if.
How do we?
Well, you have to try things out, man. Be fast because the bonus is quickly full. I think I'm leading. I have 3 points.
No idea where my brother.
Yeah, but improvise, man. And you guys know where this is going, right? As web developers, we're used to asking this question: does it scale?
Yeah.
Does it? It should, right? Okay. Now you guys are playing. Worst demo ever. Are you ready for this? Okay, let's try again. The one with most points wins. You guys can go there too, because you're not in the field of view. Oh, by the way, I should adjust the field of view of the camera. You want to play too? If you want to play, you should be in front of. I'll play. Okay. How does No, wait. What? No. Cal is winning. Oh, no, it's Zia. It's a close battle between Cal and Zia. Okay, who won? We have a close. It is Kyle. Kyle, you are the winner. I give you this microbit. Oh, you're sweet. That didn't work out so well. So that's all I got. Again, I would like to tell you to start a code club. So if any of you wants to start a code club, I brought these microbits. So if you would like to get one to teach people, just come and ask me. No question asked. But all the code and the slides will be pushed to my GitHub repo. And if you start a code club, please do send me pictures. I'd love to see them. That's all I got. Enjoy PyCon.
Thank you so much, Regis, for a very engaging keynote. Even I don't code, but I'm inspired to code. Happy to hear one of those. We have a few minutes. Does anyone have any questions for Regis? I'm working on a page of it's your desktop. My son is 7. I thought I was saying to him. He wrote out a log document out that by 23, which was kind of what was spoken at this point. But I'm wondering what
So it's difficult to gateway kids. No, you're too young. Just get out of here. So what was this website called? It's difficult to get kids to write, to type on a keyboard. It's difficult to get them to read anything that is too long. So we have these interactive exercises. That is, it's something to do with Minecraft. Wait, what was it? So there are these interactive exercises where you have to program an Angry Bird or a Minecraft character to move along a line, and you drag and drop visual blocks using a language that is similar to Scratch, and that is very engaging to very young students.
And we tried Scratch, we got some great Scratch, but then Scratch too great with the issue. We detect multiple methods.
Yeah, so there are issues with Scratch, and I think you need to you need to lower the barrier. Scratch is a little too difficult for 7-year-old kids. So I can find the URL anymore, but I'll give it to you, and I will put it in the GitHub. And we get mostly middle school kids. That's the age where they get really interested. I didn't? Oh, I did.
Thank you for the talk. It's very fun. So I actually started up myself doing a program in PyCon, PyCon. And you said that you don't need it, right? So I had this. There's also this tool called Kiwi. I don't know if you've heard of it.
Which tool?
Kiwi. It's much more user friendly. So I was just thinking that if you haven't heard of it, I was just thinking how do you think that compares to Python?
Like KEEV?
AI.
No, I haven't. But maybe it's better. So the issue I have with the Pygame is that you need too much boilerplate, and even typing a small piece of code is difficult. Also, I am really, really fond of Love2D. I mean, you have these libraries that haven't seen a single commit for 5 years. You just install them and they work out of the box. And I think this is great. It's a great ecosystem. Also, there are these courses on edX, CS50X. So it's video game programming. They start with Pong and they end with like Portal, I think. It's an amazing series. I strongly recommend it. And they do everything in Love2D. Yeah.
There it is. Great talk. Really enjoyed it. So I had a question about starting corporate for kids of age 20 plus. And the question that I have is knowledge speaking.
Yeah.
How do you start with that? What are kind of future resources that one can apply to that? Should one start with programming language like Python or something else? And what about starting with micro? Because it appears to be really nice and flashy.
So this is a great question. The question is about what about non-English speaking kids? And I live in France. I mean, even adults have trouble speaking English. And for kids, of course, it is super difficult. And there are many resources out there for learning programming, but most of them are in English. So what you have to do is really produce your own content. And one thing that we do in our code club that is super fun, it is these, what we call them base games. So this is a base bubble. This is a game that has no name. And it's all, well, it's not all in French. So I'll show you what I mean by base game. So it is, you can see me jumping. I have to jump on top of the opponents. And yeah, this is hard. I'm too old for this. Okay, I died. So the point is that this game is empty. It has no graphics. And we, the instructors, we wrote the base code of the game. Not this. And we wrote the base code, and it's all in French. We wrote the whole code in French. And it's a bit too difficult, but the job of kids is to create the graphics for this game, and also the sounds, like they can record with their mouth, using a simple sound software. And they can also design levels using a text-based interface. So this is really fun. But basically, you have to do the legwork. You have to mentor the kids in their own language, because even if they could speak English, it would be very difficult for them to follow the online resources.
So, kind of the two questions me being an instructor, I can know English, right? How do I translate and I can read English for them and translate it to my own language or whatever language they want The thing is that what could be a good starting point from trying to learn from US, right? What are the kind of languages?
So really the good starting point is it is this. It is really asking the kids what they want to do and then provide them with the materials that they need. And the instructors, they have to know English at some point because they need to learn about the languages. But then they have to build their own material. And this is really the case for any course on any either live or online course, the teachers, they have to build their own content, basically. So yeah, there is no shortcut for this, I'm afraid. We struggle with this a lot, and we just, adapt to what the kids want to do.
Any final question? Thank you.
I would like to extend my most grateful thanks to the organizing team. You are doing an amazing job, really. We're not seeing all the effort that you make. You've been great.
Sorry, wonderful presentation. Really enjoyed it. Other than the face-to-face teaching to these local students, are you using any sort of software that can elevate or something like that? Yeah, I think you are using already. You are using OpenMX to further facilitate those students to use the content and other stuff like that.
So the question is whether do we use online resources? And I wish I could. I really wish I could. I mean, I really wish I could just give an online resource to kids like OpenX, and they would just stay in front of the screen and learn all by themselves. Turns out that's not how it works. I mean, kids, they don't want to do that. They want to engage. They want the social interactions. They want approval from an adult. And this is what they really come for. They come for programming, but they stay for the social interactions. So I wish I could just give them an online course and it would be ready for them. It doesn't work that way. It's really a blended approach where you can use online tools in your sessions, but you have to be there and you have to listen and you have to talk because this is the fun part. Yeah. Thank you so much.